One of the leading issues for design respins is due to interferences with the PCB components and mechanical models. With Expedition Layout, we will go through the process of creating instance and global-based rules in the 3D domain to ensure that your assembly follows the electrical and mechanical design rules. In the first example, we will create an instance-based 3D constraint for the top enclosure and the pin header placed on the top side of the board. Optimal and minimum rules allow us to define a delta if the nominal or maximum dimensions were used to create the 3D model. We will define a constraint between J1 and the assembly top where the minimum distance must be 10 mils and the optimal is 15 mils in the X and Y direction. With Expedition's online DRC, you will notice as you move the pin header, you can see a yellow violation when it breaks the optimal rule, and you'll see a red violation when it breaks the minimum rule. As well as general clearances, Expedition allows you to define package groups. In this example, we have a mechanical cell that has been assigned a package group of heat sinks that is located on the top processor, which is a BGA. We will use this package group to assign global rules in Constraint Manager. Constraint Manager allows you to define global 3D design rule checks, where you can define rules for all components, mechanicals, assemblies, and data cards, as well as package groups. In this example, we already have some global rules created. Notice that some of the rules have a 0 value associated to them. This will exclude the rule from being checked by the online and batch DRC. In this case, we have a component to assembly rule where we need to create a minimum XY clearance of 4 mils and an optimum of 5 mils. Next, we will create a component to component rule where the minimum XY is 5 mils and the optimal is 10 mils. Once we are done with our general clearances, we can now create package group rules for that heatsink we identified in our design. We will create a rule for the heatsink package group to the ICBGA, which is the package group that the processor sits on. We will make a rule only to check the top side of the board. We will set the Z minimum distance to 0 mils as we expect the heatsink to be mated directly to the surface of the processor. The last rule we will create is a rule between all SOICs to discrete chips. We will use a minimum of 50 mils and an optimal rule of 20 mils in the XY direction. When we are done, we will close Constraint Manager to update our layout design with our new constraints. As well as online DRC, users have access to batch 3D DRC within Expedition. Here, the users can immediately identify violations within Hazard Explorer. Designers can view the violation and even shadow components to view the exact location and distance that a failure has occurred. In this violation, you can see that we have an oscillator, Y4, is breaking an XY clearance of 10 mils when it is actually 8.8 mils. Online and batch 3D DRC will allow the electrical designer in Expedition to identify interferences throughout the design process. This will speed up the design review and identify any potential issues that may cause a violation and a respin.